The reason for Curemaster PCR is because of certain areas of the world require different functionality. From individual cavity in mainly Europe and America, some Asian countries and Southeast Asia required combined cavity. So we decided on a new concept where we have combined cavity. It's more or less to penetrate certain markets of the world and was developed on that background. Individual cavity is where each cavity can work separately, and you can have different molds in each cavity, and you can stop one and cure on the other one. Combined cavity is where both cavities move at the same time, and you have to have the same molds in the press to be able to function correctly. If you have high production facilities where you have high volume and long production runs, combined cavity is an advantage. In lower areas and in smaller tires, 13, 14, 15 inch in some areas of the world are still predominant, and it's high production run. Combined cavity has an advantage over individual cavity. Yes, we see the trend in the marketplace that bigger tires become more important, and obviously that brings also press. That's why it was developed for 52 inch, that we can cover the bigger sizes too, but it also has to say if you run a bigger size, you can also do, if you have high production runs, you can still do it on the same machine. Obviously the machine has a different functionality than our normal PCR press, where we have a different squeeze force arrangement, which gives us better uniformity, better mold life. So it has distinct advantages in the system. I think it will be the way we've designed it. It's very modular, easy to install, easy shipment in one container, and our installation time is 3 days. From press unloading to power on, and if the steam or nitrogen is ready, we can actually cure tire on the 4th day. It's already released basically for quotation purposes. We are already in discussion with several customers regarding Curemaster PCR. The press is basically developed. We have put on new technology onto the machine, which makes it more cost effective, specifically from an electrical point of view. We've also added some functionality for digitalization, where it's easier to connect to the machine to get the data out of it. So at any point in time, if a customer requests the machine, we can actually produce it and deliver it. It's very important for us because we see mechanical presses are coming to the end of life cycle in many situations, and this press is specifically developed to go into a mechanical press size, and it's a one-to-one replacement with any mold that you would like. Any height, any diameter up to 52 inch we can handle within the Curemaster. So we're not limited to specific mold type. We can run any type of mold on it, segmented mold, whatever. It's no issue at all. It will be an option for the customer to go either conventional with steam heating, but as you know, we're also developing an electrical heating solution where it can be retrofitted or can be supplied as a new press with electrical heating included. You have to look at it theoretically and say, where do you want to implement electrical curing? Obviously, electrical curing comes with a lot of obstacles, not only from the machine manufacturers, but also from the plants. First of all, you have to ask, can the infrastructure within their facilities handle the amount of power? So they also face a lot of obstacles to increase their power consumption, and that is not always easy because tire factory uses a lot of power, specifically in mixing and extrusion area, and then you want to convert 180 presses maybe in your facility to electrical curing. It will add an enormous amount of consumption to your electricity, and do you have the infrastructure for that? Is there enough supply in the area? So they face a lot of challenges. On our side, yes, we also face a lot of challenges to make it cost effective. From the results we see at the moment, yes, there is an energy saving, but we also have to look at it, what can electrical heating brings in terms of process? Can we save time on the curing process? So you have a dual benefit, not only in a reduction of energy, but also you can reduce your curing time, which gives you more output and more efficiency for the same amount of machines. So there's a little bit of A and B that have to come together to see the real effect. To say, in our experience, to be more conservative, we see between 15 to 25 to 30% energy reduction in a tire curing cycle, but that is still in the evaluation process for us to validate that. I think in Europe it's the most prominent area for electrical heating because you have to deal with a lot of other factors. It's not just the electrical cost, but if you have, for instance, a steam boiler, you We have to deal with the CO2 emissions and CO2 taxes. So if you take all the parameters into the equation, electrical curing is still more cost effective than steam heating. Yes, absolutely. Absolutely. But for e-heating, it depends on what technology you have. Yes, you have to make sure that your equipment is safe. There's a lot of tests going on to meet the CE certification and C norm certification within the curing press. I think a lot of people overlook that point a little bit. To supply machines in Europe, it's quite stringent with the rules and regulations, and that you have to take into consideration when you develop these systems. But from a safety point of view, yes, I agree. Electrical heating is more safe because there's no real steam that can go, but for the internal heating you might use heated nitrogen, but nitrogen comes with different, I would say, factors that you have to consideration because you cannot see it and you cannot smell it. So if you have a leak, it could be dangerous. So we have to put other systems in place to detect if there is a problem on the system to make sure that the operators are safe. Specifically, if you work down in the behind the press, there could be some risk, but we've taken all those factors into our risk assessment and evaluated and come up with workable solutions to make sure that the operators are safe. Yeah, I think there's a lot of opportunity. You know, electrical heating brings in a complete new dimension into the supply chain. That could be good growth for HF. In general, you see the market a little bit stagnant at the moment. Yes, there are growth in certain areas of the world, but in Europe mainly we see a lot of tire factories closure coming up in the next year or two, which could affect the business in Europe because companies might shift equipment from A to B. So that could impact us, but you know, we have a wide customer base and we supply all over the world. So yes, it impacts us maybe in one area, but in the other area we gain again, so we are quite balanced. This year it will be around between the same 350 to 400. If I look at our production, is quite full for the year till the end of this year because of the backlog from previous years and new orders coming in, because supply chain is improving, so our delivery times have drastically improved. So we can deliver back, we're almost back to pre-COVID times where delivery time now is between 7 and 8 months. But in the next few months, we should be able to get it back to our normal delivery of 6 months procuring. India market is obviously the hot spot at the moment, I think. We see a lot of growth potential there. We don't have a huge presence at the moment, but we're working on that part to improve our presence in India significantly. And Asia is always a hot spot, and obviously North America has a lot of growth potential. China is a difficult market. We have a lot of costs, a lot of competitors, and it's mostly cost-driven, functionality, and it's more of a capex thing. They don't very much look in the OPEX part where the operational comes into effect. So it's more focused on capex, and in some areas we face some obstacles. I think there will always be improvements. It's always got to do with cycle time in the curing process. How can we make it better, more efficient, energy saving? As you know, the press is completely different design. It is also to look at quality. For the curing, how can we improve the uniformity? How can we save the customer some mold life? How can we reduce maintenance? So there's a lot of factors we're working on to make it as close as possible to perfect. But as you said, you will never get it 100%. But I think there's a significant improvement within the system, especially from a structural point of view. We've eliminated most of the risk now. I think we will be driven into a direction of sustainability will be the main focus, and product development from a quality point of view. I think curing is not going to become easier with new materials that they are implementing, so it will become a bigger challenge. They will obviously require a higher level of automation because of skilled people becoming very difficult to acquire to work in the factories and maintain the equipment. So automation, high technology and energy efficiency, we see developments maybe in the next year or two where we will not use steam anymore or any hydraulics. It might be fully electric curing press. I think there's a lot from an energy point of view. You know, we obviously have HF Explore where we're connecting that to our new systems where we track and trace all the energy consumption to actually give the customer all the data that he requires from cost per tire, how much energy in which area of the tire is going in. And then digitalization on the press and new product development, and obviously safety is a very important part.